a Ober in Tasmania. Alla biologa australiana gli fu conferito nel 2009, insieme al suo team, il premio Nobel per la medicina, in merito ai suoi studi riguardanti i telomeri e l'enzima telomerasi.
But there is a glitch in the way DNA is copied. It is just one of those facts of life. Every time the cell divides and the DNA is copied, some of that DNA from the ends gets worn down and shortened, some of that telomere DNA. And think about it, like the protective caps at the ends of your shoelace, and those keep the shoelace or the chromosome from fraying. And when that tip gets too short, it falls off, and that worn down telomere sends a signal to the cells. The DNA is no longer being protected, sends a signal, time to die. So, end of story. Well, sorry, not so fast.
Forse incentivata dai genitori, Elizabeth studiò all'Università di Yale per poi unirsi alla facoltà dell'Università della California nel Dipartimento di Biologia Molecolare. Definita la regina dei telomeri, Elizabeth è oggi docente di biologia e fisiologia sempre all'Università della California. Ha speso gran parte della sua vita nella ricerca dei telomeri e dell'enzima telomerasi. Tutto nella sua ricerca Elizabeth lo deve ad un organismo unicellulare, ovvero la tetraechmina, conosciuta anche come alga di stagno. Quindi sì, la sua carriera è proprio dovuta, è iniziata grazie a questo organismo unicellulare, ovvero questa alga di stagno.
Now, for me, this little pond scum critter tetrahymena was a great way to study the fundamental mystery. I was most curious about those bundles of DNA in our cells called chromosomes. And that was because I was curious about the very ends of chromosomes, known as telomeres. Now, when I started my quest, all we knew was that they help protect the ends of chromosomes. It was important when cells divide. It was really important. But I wanted to find out what telomeres consisted of, and for that I needed a lot of them. Now it so happens that cute little tetrahymena has a lot of short linear chromosomes, around 20,000, so lots of telomeres. So it was thanks to their plentiful telomerase that our pond scum critters never got old. Okay, now that's an incredibly hopeful message for us humans to be receiving from pond scum, because it turns out that as we humans age, our telomeres do shorten, and remarkably, that shortening is aging us. Generally speaking, the longer your telomeres, the better off you are. It's the overshortening of telomeres that leads us to feel and see signs of aging. My skin cells start to die, and I start to see fine lines, wrinkles. Hair pigment cells die. You start to see grey. Immune system cells die. You increase your risks of getting sick. In fact, the cumulative research from the last 20 years has made clear that telomere attrition is contributing to our risks of getting cardiovascular diseases, Alzheimer's, some cancers, diabetes, the very conditions many of us die of.
Come avete visto dal video, questo è il motivo per il quale le fu conferito il premio Nobel. La sua scoperta non fu solo sconvolgente per l'epoca, ma tutt'oggi è molto importante per gli studi riguardanti il cancro.
A study from the University of California, Los Angeles, of people who are caring for a relative with dementia long term, and looked at their caregivers' telomere maintenance capacity and found that it was improved by them practicing a form of meditation for as little as 12 minutes a day for 2 months. Attitude matters. If you're habitually a negative thinker, you typically see a stressful situation with a threat-stress response, meaning if your boss wants to see you, you automatically think, I'm about to be fired, and your blood vessels constrict, and your level of the stress hormone, cortisol, creeps up, and then it stays up. And over time, that persistently high level of the cortisol actually damps down your telomerase, not good for your telomeres. On the other hand, if you typically see something stressful as a challenge to be tackled, then blood flows to your heart and to your brain, and you experience a brief but energizing spike of cortisol. And thanks to that habitual bring-it-on attitude, your telomeres do just fine. So, what is all of this telling us? Your telomeres do just fine. You really do have power to change what is happening to your own telomeres. But our curiosity just got more and more intense because we started to wonder, what about factors outside our own skin? Could they impact our telomere maintenance as well? You know, we humans are intensely social beings. Is it even possible that our telomeres were social as well? And the results have been startling. As early as childhood, emotional neglect, exposure to violence, bullying, and racism all impact telomeres, and the effects are long-term. Can you imagine the impact on children of living years in a war zone? People who can't trust their neighbors and who don't feel safe in their neighborhoods consistently have shorter telomeres. So your home address matters for telomeres as well. On the flip side, tight-knit communities, being in a marriage long-term, and lifelong friendships even, all improve telomere maintenance. So what is all this telling us? It's telling us that I have the power to impact my own telomeres, and I also have the power to impact yours. Telomere science has told us just how interconnected we all are. But I'm still curious. I do wonder what legacy all of us will leave for the next generation. Will we invest in the next young woman or man peering through a microscope at next little critter, the next bit of pond scum, curious about a question we don't even know today is a question? It could be a great question that could impact all the world. And maybe you're curious about you. Now that you know how to protect your telomeres, are you curious, what are you going to do with all those decades of brimming good health? And now that you know you can impact the telomeres of others, are you curious, how will you make a difference? And now that you know the power of curiosity to change the world, how will you make sure that the world invests in curiosity for the sake of the generations that will come after us?
Attenzione, la cosa sconvolgente è che i telomeri, in base ai suoi studi, si modificano anche in condizioni di stress, quindi mi raccomando, siate felici.